For this lesson, we're going to be looking at factoring again. In a previous lesson, we looked at factoring what are known as simple trinomials. In this lesson, we're going to be taking a look at factoring complex trinomials. Now, the first thing I want to point out here, a complex trinomial, the leading coefficient of the quadratic term is not equal to 1. And something I didn't say here but is worth mentioning is, of course, all of this assumes that the leading coefficient of the quadratic term is not 0 as well. If the leading term of the quadratic were 0, this whole term would become 0, and then we would end up just with a linear equation. So that would defeat the purpose of what we're trying to do here. We want to keep a quadratic. So we have looked at a few methods on how we can do expanding and also how we can reverse that process and factor. And one of those methods was algebra tiles. Now, I've mentioned this in class and probably in the lesson as well, the online lesson, which is using algebra tiles does start to get a little awkward as the coefficients and the numbers involved here start to rise. Sometimes algebra tiles can work very well. They work very well for illustrating simple problems, but even something like this, so 3x squared. Now, fortunately, I chose 3x squared. There's really only one way I could lay out 3x squared. I guess I could have done it vertically as well. And then plus 7x. Now, this is where we have decisions to make. Now, if you're going to be using tiles to factor, I really recommend you do your quadratic term, your x squared terms first, and they go in the top left-hand corner. And then you take your constant terms, and they go in the bottom right. And when you think of it that way, there's only two ways that I could lay out these constant terms. It's okay for me to choose. There's really only two ways for me to do this. I just go ahead and pick one. And now I have to experiment a bit. So what are my options if I do it this way? Well, I could do 2 positive x's here, and I could do 3 positive x's along the bottom. But I think you can see that that's not going to give me the 7x that I'm looking for. I only end up with 5x there. On the other hand, if I were to line these ones up vertically, then I dispose of this and I put 3 more here along the bottom. And there we have positive 7x. And so this one gives me, I have an x along the side plus 1. So here I have an x, and an x, and a positive 1. And then here I have an x and a plus 1 and a plus 1. And so all told, based on the side lengths, I have a 3x plus 1 along the top, and I have an x plus 2 down the sides. And so that is the reverse process. That is factoring 3x squared plus 7x plus 2 going the other direction. Those are the two different factors. 2x squared minus 5x plus 3. So again, 2x squared, I could either line it up this way or this way. Just based on, in my case, screen size, I'm going to go horizontally here. And then 3, again, I'm actually doing this. You could think I'm doing it for your sake, but I'm also doing it for my own. There's only really two ways I could arrange this one, and that is a horizontal line or a vertical line. So since this is where I've landed, so let's go ahead and try this one. We want minus 5x plus 3. So minus 5x, well, that means I'm going to need negatives. So there's a negative x, and then even as I start to fill this in, I realize, well, that's not going to work. And while I'm here, I might as well warn you away from this. This is not permitted. Even though this doesn't actually get me where I want anyway, you can't have these two tiles of the same type but opposite sign. They can't be next to each other. So that doesn't work. So I'm going to back that all the way out to this other configuration. And now I'm going to try bringing in 3 negatives. And this is interesting because this is a negative 1 on the top here, but this is a positive 1. So what do I need to multiply this negative 1 by to get a positive 1? I need another negative 1. And you can see by doing that, I end up with a negative 5x. And so all told, I have an x here, negative 1, 2, 3, total of negative 3. I have an x here, a negative 1, and so factored, this is equal to, I've got 2x's minus 3, and then I've got an x minus 1. Finally, 2x squared, so again I've got the option 2x squared, I'm going to lay that out horizontally, negative 3. So this horizontal configuration worked for me before, so I'll try that this time. Negative x. Now whenever you see something like a negative x and you've got a bunch of spaces left here, you should be thinking I'm going to be doing some alternating between positives and negatives. Because remember, whenever I have a positive and negative together, they add up to 0. They cancel each other out. So what if I were to actually let's put a little bit more thought into this. I've got 3 here, 1, 2, 3 spaces, and I've got 2 spaces here. But overall I want to end up with a negative. So what do I need more of? Do I need more positives or do I need more negatives? And the answer to that is I clearly need more negatives. So for example, here is 2 negatives and 1 positive, so that's overall negative 1. Here's 3 negatives and 2 positives. That's still overall a negative 1. And it turns out that's the grouping that I actually need here. I'm going to put those 3 negatives vertically, 2 positives horizontally. And we want to check this, so we've got our x times x is x squared. This is plus 1. So here we have an x, here we have plus 1. Here we have an x, here we have an x, here we have negative 3. And then this negative 3 times this positive 1, negative 3 times positive 1 is negative 3. So that works. So along the top I have 2x minus 3, and along the side I have x plus 1. It doesn't matter the order that I write these two factors. I could read it along the side first and then along the top, or along the top and then along the side.